Hi, today we're going to be talking about how to write electron configurations. Now, I'm going to be showing you guys a nifty little shortcut that hopefully will make this whole off-bow principle and Hund's rule and all of that as simple as possible, okay? Now, the basic concept is, as hopefully you know by now, is that electrons are lazy and they want to occupy the lowest energy level possible. All right. And the periodic table is actually set up in order to show that. It's kind of crazy, but it actually is set up this way. Now, as you guys know, there are lots of different types of orbitals, and they have different shapes. Okay, you can kind of see it over here. That the different shapes are like if you have an s orbital, the s orbitals are all circular. Okay, everything here in the first two columns of the periodic table, their last electron is in the s orbital. Okay, so their last one is in the s orbital. And remember, going from top to bottom, the energy levels represent, the periods, represent energy levels. So beryllium, has two energy levels. And you kind of see that here, the little red one and the larger blue one. And these S ones are the simplest. Now, the P orbitals, first you have S, then you have P orbitals. That's all these guys over here that are, what is this, teal, I guess? All right. Now, if you notice, these guys have kind of a weird three-dimensional shape that are a little bit like dumbbells, all right, in a way. All right. So this guy, all right, and they take different shapes. So you have like up and down, left to right, and so forth. So these P ones are a little bit like dumbbells. And then you have the ones in the middle here. These are the D, as in dog, the D orbitals. All right. And these take on weird, almost quadrantal shapes. Okay, you can see how weird and those are. I'm not going to even worry about the exact shapes. I mean, if I get down, the F blocks are these guys right here, the lanthanides and actinides. These guys, if I click on one of these, you can just see how funky the three-dimensional shapes are. And remember, these orbitals are simply the three-dimensional areas where the electrons are most likely to be found. But they move so fast and they're mostly unpredictable that it's one of those weird things that by the time you actually find it, it's no longer there. But it's all about probabilities, and I'm going to try to keep it as simple as I can and say, don't worry about the actual shapes of the orbitals. What you just need to worry about are the actual configurations, okay? Now, the way the configurations work is that all of the orbitals lower have to be filled up before the higher ones can be filled in. And that each orbital can hold a maximum of 2 electrons. If it is an S, it can hold 6 electrons. If it is one of the P's, all right, they can hold a total of 10 electrons if it's a D, and they can hold a total of 14 electrons if it's an F, all right? And for the most part, there are exceptions, but for the most part, they just go straight across and they fill it in. Let me give you some examples of what it is that I'm talking about, okay? So let's say, for example, we have beryllium. All right, we click on beryllium here. Now, beryllium is in the second row, and it is in, it has 4 electrons. And the first 2 are going to be occupying, as you can see here, the 1s orbital. All right. Hydrogen fills in 1s going one way. Remember, there's different spins. Helium would then do 1s, and it's the second one there. Now that's filled. Lithium, having 3 electrons, would then fill or start filling the 2s, and then beryllium would then go filling the 2s completely. So we would say that beryllium, as you can see here, we would say is 1s2, 2s2. The first number here represents the energy level 1. The second letter here indicates that it's the s orbital, and the subscript on top indicates how many electrons are in that orbital. Now, so the s's can hold a maximum of 2. So since this is in row 2, and it's the second one over, it's simply 2s2, 1s2, 2s2. Now, if we jump over here to boron, okay, now boron's in the p's. After 2s2 comes 2p. And since it's the first one in this section, that'd be 2p1. All right, another electron, it'd be 2p2, 2p3, 2p4, 2p5, and then 2p6. Hopefully you're watching these guys over here. All right. And then the next one, sodium, well, that's going to go down to the 3s2. So it's going to have all of these guys. And then the next one you're going to jump into would be 3s1. All right, 3s1. You see that? 3s1. And then this is going to be 3s2. Now that guy's filled. It's going to jump over here. And let's take a look at chlorine. Now, chlorine is the 1, 2, 3, 4, 5th element over in this is column 3. It's going to be energy level 3, and it's the P section. So that's going to be 3p5. And you can see right here, it's going to end in 3p5. It has all the ones before it, and then 3p5. Now, once you get down to here, this is when things get a little weirder. But remember, these are, even though this is in row 4, these guys are the D block, and the D blocks are kind of like one behind. It's kind of weird. If you notice, the D block has 3. That's energy level 3 right there. So energy level 1 just has S. Energy level 2 has S and P. Energy level 3 has S and P and D as well. That's weird, I know, but it has D as well. And remember, when you're looking at the energy, if you have this diagonal rule, you can see that it goes in that each time it expands one more. You have 3D, and then level 4 goes all the way out to F, as well as level 5. But when you look at the periodic table, it doesn't have it in that row. Row 3 seems to just go from magnesium to aluminum, and it just goes from 3s to 3p. That's because the 3ds are down here. Okay? Those are all the 3ds. And then the 4ds would be here. Again, one level lower than where they should be. But the 4f's, this is the crazy part, the 4f's are here. Starting with lanthanide, these 4f's go all the way over to here. You can see it filled up that 4f energy level all the way to there. Okay? Just cuckoo. All right? But basically, you just fill it up until it is all the way filled. I don't know what they have doing there. Expanded. Configure. Okay. Now, an easier way of doing configurations, just so you guys know, is it is assumed that at the end of each row you have these guys right here, which these guys at the very left-hand side, right-hand side here, these are the noble gases. And what you can do is, let's say you want to do calcium. Calcium, if you notice, is you look at the noble gas that is right behind it is argon. Calcium has 20 electrons. Argon here, is one complete p orbital. And then it jumps down to the next S1, always. It completes a p, and then it jumps down to S. Like xenon completes a P, jumps down to an S. So what you can do is you can just go back and say, hey, look, from here all the way down to xenon, that's xenon's electron configuration. So you can put xenon, if I'm doing this, I'm going to put xenon in brackets. And that indicates, hey, look, that's all of xenon. All right, if I do the expanded, that brackets takes up all 54 of these electrons. And it just makes them a lot simpler. And then you just add on everything from xenon. So you can always just take the noble gas, that is the one behind it, and then expand from there. Okay? So let's try some of these. I'm going to do these on the whiteboard next. So the first example I want to give you is a nice, simple one. And let's take a look at nitrogens. Okay? Now, nitrogen has 7 electrons, so we need to account for all 7 of those electrons. So first of all, we have 7. And the first one we're going to do is in the first column, first row, and that's the 1s. So I know that's going to be 1s, and there's 2 of them in that row. So that's 1s2. And then here, this group over here, that's going to be it's in the second period, and there's 2 of them, so that's going to be 2s2. And then we jump over to nitrogen. This is in the second, and it's in the P group, all right, the P block. So we're going to have 2, and then P, and since it's the third one over, that's going to be 2p3. All right, so that would be nitrogen. Pretty simple. Now we could simplify it a bit, even more, and say, well, we go back, and the last one, the last noble gas before nitrogen was helium. So we could just put helium and then go from there with lithium all the way to nitrogen and go 2s2 and then 3p3. But that would be, that doesn't save a whole lot of time. You're just replacing the 1s2 with that. So usually in the first couple of rows, you don't see that too often. All right, so that would be nitrogen, would be that electron configuration. Now, let's take a look at a little bit more challenging one. Let's try iron right here. Okay, iron number 26. Now, we're starting here and we're going across. So again, let's do the shortcut version. Back from iron would be argon. So we take iron, we go backwards, and then we have argon here. So for iron, I'm going to start off with argon in brackets. That's 18 of them taken care of right there. Then I have S's. Now this is in row 4, so that's going to be 4s1 and 2. So that becomes 4s2. Then we jump over to here. Now remember, this block are the F blocks. Remember, it goes S, P, these are the D blocks. It goes S, P, D, and then F. S, P, D, and F. So on the D block right here, iron is the 1, 2, 3, 4, 5, 6th one over. So we know it's going to be D6. But what energy level is? Now, you'd be tempted to think that it's 4, but this is one of those exceptions. Remember, the 3 covers these guys as well as this block here. Remember, it kind of jumps down 1. So this would then be 3d6. All right? So that would be iron. It's argon, 4s2, 3d6. All right, let's try an even more challenging one. And let's do, I don't know if it's more challenging. Let's do antimony right here, 51. Now, we know it's going to be antimony, which is Sb. All right, we know it's going to be Sb. And we go back from antimony, and the next noble gas back is going to be krypton, number 36. So we're just going to take Kr, capital K, lowercase r. All right. And then we go up from there. So level 5, we have 5s2. And then after that, yttrium, 38, 39. Remember this, it's in row 5, but it's actually energy level 4 because it's one less. So that's going to be 4, and that's group D, okay? And so we're trying to get to antimony, so all of that's going to be filled. And this guy, if you count over, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, the D block can hold 10 electrons. And then we're back on level 5, so that's 5. And these are the P block, 5P. And then antimony is the third one over, so that'd be 5P3. All right, antimony starts with krypton, and then we just go from there, 5s, 4d, 5p3. All right, now let's try like one of the hardest ones right here, all the way down. Let's do let's do plutonium. All right, number 94, plutonium. Now remember, these guys are the F blocks. We have S block, we have P blocks, we have the center guys here, which are the D blocks, and then these two that are farther down are the F blocks. And we're looking at plutonium, number 94. So Pu. All right. So we're going for Pu. And Pu, there's 94 of them. Now we go back, and remember that goes 94. It's here. So the noble gas that comes before it is number 86, radon. Sorry, number 86, radon. Because 94, go back, 86 is the next highest noble gas. So we're going to go Rn for radon. And then after radon comes level 7, francium, and then radium. So that's 7s2. All right. Then from there, we start doing the actinides, 89 all the way over. And these are the F blocks, okay? After 7s is F blocks. Now remember, F block is 2 below whatever row it is. The D blocks, all right, the D blocks are 1 below, but the F blocks, and technically lanthanum and actinium, these guys right here, are technically the first ones of the F block. All right, it's kind of weird, but that's how it works. So actinium would be F, would be F1. This would be F2, F3, F4, F5, F6. So we know it's going to be an F6. But what level? Well, remember, if the D blocks are 1 level below the row, these are 2 levels below the row. So instead of 7, it goes back 2, so that's going to be 5. That's actually 5F6. So plutonium would be radon, 7s2, 5f6. Well, I know this is confusing. Please come to tutorial if you need help, but give it your best shot. And don't forget that you have, check out the answers on the worksheet and make sure you got them right. Good luck.